Okay, we're going to be looking at systems of linear equations by substitution. This is the second method in solving a system of equations. So the only objective is just to solve by substitution. So here is the method. Here in this green box, you're going to have two equations. You're going to solve one for either x or y, whichever one is easier. Sometimes one already might be solved in terms of x or y. You're going to take that variable that is isolated, you're going to plug it in, it says substitute, into another equation, the second one that you have. You will solve and get an answer, and then that answer you will take it back to the original equation, which they're calling back substitution, and then you'll check your answer by plugging it into both the original equations. So here's an example that they're showing you. This one is already y equal. This one has x and y on the same side. So they're going to take this y, which is equal to negative 2x plus 5, replace it right here. They're showing you that in this picture. Y equals negative 2x plus 5. They're plugging it into the second equation, and now they have x plus, instead of 2y, y has been replaced with that whole equation. You then solve it, you get an answer for x. You take that value, plug it back into the original equation, the y equals negative 2x plus 3, replacing that x, plus 5, replace that x with 3, and then you get a y value. Then you take that ordered pair, and they say you can check it by plugging it in to both of these original equations. And if you get the same thing on the left and the right, then we know we've done it correctly. So this is just another example showing you how to get that answer and then check that it satisfies both equations. You plug it in to this equation, get an answer, you plug it in to the other. Now there are some different scenarios that you need to be aware of. It's not showing up here, it's going to show up on the next one probably. Okay, so sometimes when you solve, so this one they probably solve for y, okay, and then they plug it in, and then when you simplify, both your x's cancel out. So you have 6x and minus 6x. So you don't have any variables left. And the statement that you're left with is 2 equals 3. If you get a false statement like this, they're saying that 2 is not equal to 3, that's false. So that means this is inconsistent, which means there's no solution. So if you solve both of these for y, you would notice you would have the same slope. However, in another scenario, if you plugged in, solved, and your variable canceled out, whether it be x or y, and then you ended up with something that was true, like 3 equals 3, then that means you have an infinite number of solutions, and that means that these would be the same line. The way that you would plug that in to show the solution is you would pick the variable. So if you solve one for y, you pick that variable, and then you would put the y on the other side, and vice versa. If you had solved for x, you would let y be itself, and then you would let x be the equation in terms of y. So we'll see that when I do a couple of examples for you. Kind of harder to understand by looking at it here. And then you just have another example that they're showing you here. Okay, so with that, I'm going to jump into Hawks and start doing some examples for you.